The real image was captured from the solar explosion that occurred on August 8, 2024. On that day, the most powerful solar telescope ever built broke all previous records. A massive solar flare with X-ray intensity was detected from the Hawaiian Observatory, where the telescope captured photos of the explosion's wreckage. The plasma tubes of the Solar 100 Khorshidi 100 measured about 21 kilometers in diameter, one of which had only been imagined before this event. The explosions of the Solar 100 began during this stage and extended even farther below the visible solar surface. On one particularly sunny and clear day, the Dickey telescope was taking high-resolution photos of the sun from Hawaii. That day, the telescope reached its maximum operational capacity, and precisely at that moment, an explosion of the Solar 100 occurred, with an X-ray power level between X 1.3 and X 1.6. The Solar 100 was active in the upper atmosphere, and this X-ray flare turned out to be the most powerful ever recorded. The solar explosion of the Solar 100 produced the most intense burst of radiation, though the measured energy output was relatively low. But here was the main issue. Until this event, no image of such quality and precision had ever been captured. The telescope's light sensors were designed to detect hydrogen waves, essential for mapping plasma structures in solar flares. The Solar 100 itself turned out to be something extraordinary. The images revealed a hidden orbital pattern, traces of solar matter, and detailed views of coronal loops within an enormous magnetic range. In the higher solar atmosphere, calculations showed structures between 21 kilometers and 48 kilometers in scale, the brightest coronal waves ever recorded. A century ago, scientists could only theorize about such an image, since there were no satellites or advanced telescopes to capture it. But now we have reached the real evidence. This telescope is exceptionally well engineered, featuring a 4.5-meter indirect mirror, allowing it to observe the outer structure of the blazing solar mass. After passing through 10 optical mirrors, the sunlight is concentrated and analyzed with extreme precision. That is the moment we reached, a place we had never been before. In earlier years, the images were of poor quality, but now the new photographs have completely changed that. The fine plasma threads, with diameters up to 21 kilometers, show that these holes are actually streams of magnetic plasma, extremely hot and moving at incredible speeds. This demonstrates that the sun's magnetic fields create these fine lines, and when the magnetic connections between them fail, the result is a catastrophic solar explosion. These new images fill in the missing pieces of solar models. Earlier models had attempted to represent these lines, but the focus was never detailed enough. Now, scientists can zoom in on the minute structures, bridging the gap between scientific observation and theoretical modeling, between reality and imagination. The difference between the magnetic threads themselves is a new discovery. The explosion of August 8, 2024, revealed the formation of a flat structure at the start of the flare, including a high ring and connecting magnetic filaments. This shows that the coronal rings are not uniform as once thought. Instead, they are composed of extremely dark, thin, flat lines. apparently all activities within the solar 100 originate from. These fine magnetic threads, much like molecules, are built from atoms. Here, we see the endless network of magnetic lines that power the sun's complex behavior. This discovery changes everything. Rather than treating coronal waves as continuous, scientists now understand they break into smaller fragments known as the solar plexus. The solar plexus is an essential component of solar energy dynamics. However, the truly critical issue is its effect on Earth's orbit and environment. The waves and emissions from the solar plexus influence the air, water, and electromagnetic balance of the entire system. They affect everything from airplanes to electric vehicles. For example, in 1989, a massive solar storm caused a 9-hour power outage in Canada. In 2003, another intense solar event disrupted communication, satellites. And today, the situation is even more serious, especially with our dependence on the internet and global power grids. The solar plexus represents a crucial part of the Earth-Sun relationship. It accelerates energy charging dramatically, allowing us to record over 1/3 of all solar emissions and even map local energy patterns on Earth. The use of data from the solar plexus has continued for decades, offering deeper insight into solar behavior and stellar evolution. If there is a star like the Sun, then there are countless others like it across the universe, some similar, others very different. Red giants, red dwarfs, blue stars, massive, scorching, and volatile. This is profoundly important because it shows that the Sun, giant star itself, influences all nearby planets. The question is whether these unique features of the Sun exist in other stars, and if so, how they might affect the existence of life elsewhere. Perhaps one day, not today, maybe millions of years from now, humanity will even create a star of its own. These discoveries mark the beginning of that journey toward understanding and harnessing stellar power. The Sun is a vast, monumental, and incomparably powerful star. And yet, recent developments have taken us even further beyond that understanding. And finally, for those looking for tools like Fidgeter Plus, a platform for creating and publishing AI-generated images, videos, and 3D models, it offers advanced capabilities to design characters, logos, clothing styles, and visual scenes using artificial intelligence. It supports both 2D and 3D intelligent rendering, excelling in speed, complexity, and adaptability. Thank you for watching.